Good day, everyone, and once again we are back together. Obviously, I'm only interrupting your preparation right now because there are some questions that when I see, I just think it would make an interesting discussion. All right, so I took this question on acids and bases, and I thought it would make for a very good discussion. Let's get right into it. So I took the first portion because they said, obviously I've skipped some of the questions. I just wanted to focus on this 9 mark question. All right, so the magnesium hydroxide is 0.1. They had said show it in the previous calculation, so I'm gonna skip that part, but only take the fact that the concentration is 0.15, right? So they say a group of learners add 50 cubic centimeters of a dilute hydrochloric acid solution, okay, to 40 cubic centimeters of a standard magnesium a solution rather of magnesium hydroxide, right? Now they say to us the balanced equation is given, okay? So they say that dilute hydrochloric acid solution was obtained by adding 5 cubic centimeters of 10 mole per cubic decimeters of concentrated hydrochloric acid to water to produce 100 cubic centimeters, right? Of dilute acid solution. Right, they say one of the ions is found to be in excess. All right. At the completion of the reaction, they say calculate the concentration of the ion that is in excess. Now, ladies and gents, when you get this question, this is actually purely stoichiometry, right? So we need to take it step by step and look at what we're given, right? So what I'm going to do is let me find out the number of moles of each of the reactants, so of magnesium hydroxide, and then the number of moles of hydrochloric acid, right? Now I'm going to start with magnesium hydroxide. Remember, I already have the magnesium hydroxide rather. I already have the concentration. Okay, so this is for magnesium hydroxide, right? So in this case, remember, I already have the concentration, but I also have the volume, right? So this would be concentration times volume. So that's 0.15 rather. 0.15 multiplied by the volume. They said to us we take 40 cubic centimeters. So that would be 40 divided by 1,000. Of course, what do we get? 0.04. Okay, so let's add that. So in this case, what do I have? 0.15 times 0.04. Okay, and the number of moles of magnesium hydroxide are 0.006 moles. Okay, right, so we've got the number of moles of magnesium hydroxide. Now let's try to obtain the number of moles of the acid so that we can see which one is in excess, right? But now, here's the thing. For the acid, what they did was they diluted it first. So they took 5 cubic centimeters and they actually made a dilute solution first, right? They added water so that it became 100 cubic centimeters. So the first thing is, let's find out the correct concentration, okay? So remember, for dilution, what you'll use is this this equation here. Okay, so this is before we diluted it. Okay, and this is afterwards, right? So this is for the same thing, for the hydrochloric acid, right? So they said we took 5 cubic centimeters of a 10 mole per cubic decimeter. So the concentration initially was 10. Okay, I'm not sure why I wrote C2 there. So that's 10 times the volume was 5. Now there's nothing wrong with keeping it at like in cubic centimeters, right? If you want to, you can convert to cubic decimeters, right? But that's really up to you. I'm going to keep it in cubic centimeters because even the after we diluted it, the volume was still in cubic centimeters. Okay, so for as long as those volumes are in the same units, right? So that's going to be concentration 2. So I want the concentration afterwards. Okay, and they said we made 100 cubic centimeters, right? So to get the second concentration, of course, I'm going to divide by 100 on both sides. Okay, so, right. So if I look at that, so that's going to be 10 times 5, that's 50, divided by 100. In this case, that would definitely give me 0.5. So it means that the concentration of my acid was 0.5. Okay, right. But now, what do I want? I want the number of moles. Remember, they said we took 50 cubic centimeters of that dilute hydrochloric acid, right? So now what I'm going to do is say, okay, so number of moles of hydrochloric acid, that's concentration times volume. So that's 0.5 multiplied by, remember the volume must be in cubic decimeters in this case. So how much did we take? We took 50 cubic centimeters. So that would be 0.05. That's 50 over 100, right? Okay, so let's calculate there quickly. So that's 0.5 multiplied by 0.05, and I get 0.025. Okay, so that's 0.025 moles. Now these are the moles of hydrochloric acid. Remember, where are we going? We want to find out which one is in excess between the two. Okay, now when I look at magnesium hydroxide, we had 0.06 moles that were given, okay, that reacted. And for hydrochloric acid, you've got 0.025 moles that actually reacted, right? I mean, that were available, right? Now, which one is in excess? Now, remember, their ratio is 1 for every 1 magnesium hydroxide. See, when you look at it from that perspective there, so for every 1 of this, you've got 2 of that, right? So I want you to think about it. So when I look at that magnesium hydroxide, right, if it's going to react completely, how much hydrochloric acid would you need, right? So for every 1 mole of magnesium hydroxide, you need 2 moles of hydrochloric acid. Okay, now remember, what is this? This is the amount of moles that were available. So I would say this is the initial number of moles of hydrochloric acid. Now what am I trying to find out? I'm trying to find out how much hydrochloric acid reacted, right? So the question is, when I've got 0.06, right, it is that 0.006. Let's make sure that we get that right. 0.006 of magnesium hydroxide. The question is, how many moles of HCl, right, will react? Okay, so let's cross multiply. So n times 1 in this case will be n, okay, and 0.06 times 2, that will give me 0.012 moles. So these are the number of hydrochloric acid moles that are going to react. But how many did we have, ladies and gents? We had 0.025 initially, right? So how many would be in excess then? So the number of moles that would be in excess in this case of hydrochloric acid would be the initial minus the number of moles that react. Okay, so you've got 0.025 minus 0.0 1 2, and of course the difference between that would give me 0.013 moles, right? Now, ladies and gents, all that you simply do in this case is that we now want the concentration. Remember, the question said calculate the concentration of the ions that are in excess, okay? And by the way, okay, they said ions that are in excess. So remember, hydrochloric acid, when it ionizes, it forms hydronium ions, right? So in this case, it means that our H3O plus, remember they asked whether it will be H3O plus or OH minus. So in this case, please remember that H plus and H3O plus are exactly the same thing. If you really want to be pedantic about it, you can write it in full, showing the water molecules. So you get H3O plus plus Cl minus. So what I'm trying to get you to is that for every 1 mole of hydrochloric acid, you also get 1 mole of hydronium ions. Okay? So that means therefore that the number of moles of hydronium ions would also be equal to 0.013 moles. Right, now ladies and gents, let's get to the concluding part of this. Right, we wanted the concentration, so we know that concentration of hydronium ions will be equal to number of moles divided by volume. Right, so this will be 0.013 divided by, now what is our volume in this case? Remember that we added the 2 to each other, right? So we added the 50 cubic centimeters to the 40 cubic centimeters. So our volume rather is 90 cubic centimeters. So in this case, that's going to be 90 divided by 1,000. Okay, so that would give us 0.09. Okay, so let's just quickly find out there. So that's 0.013 divided by 0.09. Okay, so I get a concentration of 0.14 moles per cubic decimeters. I hope I've got that one correct. Yeah, moles per cubic decimeters. Ladies and gents, and that is how the cookie crumbles. I hope that you enjoyed this question, that it will actually make a difference in your preparation. Otherwise, from me, I'll see you guys again later. Sharp, sharp.